Hi everybody. Here's the next in the series of videos that I'll be posting. So for this video, I'm actually just going to go over the hydropathy example that we had at the end of class on Thursday. The goal here is to get you to understand some of the decisions that I made and some of the things that you need to do to build the script that I asked you to build. So if we look specifically at what I had asked you guys to do, um, I had asked you to develop a program called Kyle Doolittle Hydrophobicity.py, and that within this program, you needed to create a dictionary of hydropathy scores for each amino acid residue using an appropriate reference, and then calculate the hydropathy scores for the following peptides. And lastly, I wanted you to tell me whether or not you thought that those peptides were hydrophobic or hydrophilic by looking at that score, with a negative value meaning that it was hydrophilic and a positive value meaning that it's hydrophobic. So if we just think about this from a pseudocode perspective, the steps that I would first break this down is, what do I need to do? First, I need to create a dictionary of hydropathy scores for all amino acids. Then I need to sum up the hydropathy scores associated with a specific protein sequence. Looking at that, notice that, okay, I've already got the hydropathy scores in there, but the thing that I don't have is I don't have that protein sequence. So at some point I'm going to have to input in a protein sequence. Last thing I want to do is I'm going to output the final hydropathy score for the sequence and whether the sequence is from a hydrophobic or hydrophilic protein. And this becomes identified, so whether something is one thing or another is determined whether the hydropathy score is either positive or negative. And when I have this case about whether something is one or the other, I can treat that as an if-else statement. So that's a pretty straightforward way to thinking about it. There's a couple different ways to create a dictionary, right? So we think about these being the 4 steps of the program that I have to do. So the first step was to create a dictionary, and all of you guys did an okay job of sort of identifying the general structure that you'd want to do. But how you would have gone about it is you would have need to have made a variable name for your dictionary. And then you could start adding in each value individually. So you could say, we're going to put in a value that's associated with the letter I, the key I, and that value is going to be equal to 4.5. And then I could add in another letter, write another key as a letter, and that could be V. That's going to be my new key, and the value is 4.2. And then I could go on to the next one. And on and on. Now you notice in all these cases that I'm using the letter as the key. And this is the easiest way to do this because you are going to be putting in a protein sequence which will come in as a string. So having the letter be a string, the key be a string, as well as your protein sequence makes a lot of sense. And then I know that every I is associated with a specific value. I could also add in these values all at one time using the following code, where I simply use the curly brackets to define what I want to call a dictionary, and then start adding in values for each one of these entities. The key point here is to remember that I want each of these values to be a float and not a list. A few of you had went through and started putting square brackets around these values, and that would actually make it a list, which makes accessing a little bit more difficult. So regardless, you can put your sequence in and it looks something like this. So at this point we have created a dictionary of hydropathy scores for all amino acids. Next thing I did is I created a way to input my protein sequence using raw input. So here I am allowing sequence input using raw input command. And what this is going to do is this is going to set the variable protein sequence to whatever sequence I want it to be. Next, I'm going to have to sum up the values of these hydropathy scores, which means I'm trying to calculate a score. There's a couple different ways for me to do this. But the first thing is that I need to create a variable to hold this score. So here I'm going to initialize a variable to calculate the score. For my sequence. There's a couple different ways to do this. So I could just do something like I could take each value and add it up. So the score equals, if we are going to take an example sequence, comes from insulin, it looks something like this, right? I could start by saying, okay, I could take the HP score for M, right? And I could add it to the HP score for A, and I could add that to the HP score for L, plus the HP score for W, plus the HP score for M, etc. However, this is a pretty lengthy, long way to go about doing this. Plus, you notice that I'm putting in multiple M's. So I could also do this a different way. I could say, okay, how about score equals prot seq count M times HP score M. If I did it this way, right, it's going to count how many M's are in my sequence, 1, 2, and give me the number 2 times the value 4.5. I could then go on to do this for each of these entities. Right, I could continue to add on the values for each letter, right? In this case, we have 1, 2, 3, so it would be 3 times the HP score for A, which is 1.8. And I could continue to go through and do it for each one of these nucleotides. The problem with that is that there's not all 20 amino acids, There's not all 20 amino acids in this sequence. Plus, I'd have to write 20 codes of this, and as you notice, as I start to write more of it, it's just going to keep going and going and going. And I could do this for all the full set of amino acids, but it becomes a little bit tedious, as I'm sure you all realized from your time in class. Now, this definitely works, so it is a solution, but it may not be the solution that you get that you feel is the most time efficient. To do that, one thing you can notice, and this is the most important part of what we're talking about here, is you notice that I start writing lines of code, and that code is redundant, right? It's repetitive. It's the same code. What's the only thing changing here? The only thing changing is the sequence letter that's in this position. So as I go through this sequence, the only thing that's changing is what letter is in this sequence. Each other time, it's staying exactly the same. So that tells you that if you have a variable that's changing, if I could create a list of the entities in that variable, I could then loop through them. And one of the things that we know is that each of the spots on a list, or that we know that a string is actually a list of letters. Using a loop, we can then say, hey, for I in range of the length of the list, we can then cycle through each entity of that list. You could also do it this way. You could say, for letter in proteseq, you could return the letter, right? And so that means that you have a list of sequences and each time you run this for any given sequence, it's going to take the value of that HP score associated with that letter and add it to the score. And this way you don't have to do the count where you have to count them all at one time. You can just count each letter as it appears. So if I write this, if I run this program, and I give it a sequence, oops, I didn't save the program first, hold on. What it'll do is it'll take each letter and it'll add that value to the score. Then it'll take the next letter and add that value to the score. Then it'll take the next letter and add that value to the score. Then it'll take the next letter and add that value to the score. In this place, it goes through the entire sequence, and no matter what sequence I give it, whether I give it the insulin sequence or I give it the embryogenesis sequence, it'll still calculate whatever values because all of the letters are in the dictionary. So as long as it can go through and call these things, it'll be able to get the associated score. Now, this is one way to do it. I actually prefer to write this loop in a slightly different way. And for that way, I actually want to use the number. So I'll say for I in range length prot seq. Right? And here this says, well, how long is the protein sequence? And instead of cycling through each item, I'm going to cycle through it by index. So if you want to think about it this way, if I were to run the sequence as such, all it does is print out each member of the sequence. 1, 2, 3, in order, right? So this is actually position 0, position 1, position 2, position 3, position 4, etc., etc. Where this comes in handy is I can use this same way of using the index to access the letter at a specific spot by calculating the score by putting that value into the key. Then if I run my example, forgot an S there. Then if I run the example, oops. I get the exact same score that I would have otherwise. Lastly, I had to output the final hydropathy score and put out whether or not the sequence was hydrophobic or hydrophilic. So in this case, I can put out the score and then use an if statement and say if score is greater than 0, print sequence is hydrophobic, or use an else statement to output it if it's hydrophilic. If I now run the same sequence, oops. It not only puts out the total score, but now will put out whether or not it's hydrophobic or hydrophilic. So that's the reasoning about how you might create this for loop and this dictionary. I think the key point to remember here is that when you run into redundant code where you find yourself doing the same thing, that's an indicator that you should be writing a loop for that component. And the key part there is to figure out how do I change how do I represent writing a loop representing what changed in this case. So instead of also doing this count shortcut right, I did the case where I was just adding each of these entities to my score individually. All right. Make sure to take some time to finish the quiz online, and hope you guys had a good weekend.